Hear me?
Yep.
Cool. I think all of the information that you guys need from me in general is going to be up on the not Moodle Blackboard page. It's got obviously this Zoom link. It's got the MRC information. If you guys have never used the MRC before, it's just the Math Tutoring Center. I posted the link and my hours there, and then also just the general available hours. You can go anytime that it's open, and somebody will be able to help you. Do people have any? Oh, I plan on recording these and then posting them onto YouTube, so you guys can go back and reference them if you're having any issues. Do you guys have any specific questions about this worksheet? If not, then I plan on just kind of going straight through some of it. Has anyone actually looked at this worksheet?
Yeah.
Did you have any issues, any specific questions that you want me to cover first?
I had trouble with 10 and 11.
Okay, cool. So I'll start off with 10 and 11 then, and then I'll just work my way back up to the start. Cool. So find the domain and range of this guy, or of these guys. So what is the domain and what is the range? What are the definitions of those things?
The domain is all values of x if the function exists, and the y is for range.
Yeah, exactly. So the domain is the functions or the values that you can map from, and the range are the values that you can map to. So if we look at the function e to the x, what does it look like? So at 1 or at 0 is 1. At 1 it's roughly 2.78. Sorry, that is not 2.78. Yes, that's about 2.78. And then by the time you get, that's also not 1. Sorry, this grid is throwing me off a little bit. So this right here would be the 1, 2, 3. Cool. And then by the time I get to 2, it's already up here somewhere. It's close to 9. And then what about at -1? It's somewhere around 1/3. It's a little bit more than 1/3. And then it keeps on decaying. So the map of e to the x looks something like this. And it's never going to quite hit 0. We can get as close as we want to 0, but we can never actually touch it because we just keep on shrinking this, but then it goes off to infinity. So what does that tell me that the range is going to be? What y values can I hit?
Is it negative infinity to positive infinity?
Not for the range. For the domain is negative infinity to positive infinity because I can put in any value for my x value and I'll get out a valid y value.
Oh yeah, that was for the domain, and the range would be 0 to infinity?
Exactly. I can get any positive number, but I can't get 0 and I can't get any negative numbers. And the other way around, e to the negative x is it basically just looks like you flipped the function around the y-axis. So how is that going to affect our domain and range?
It's going to be the same.
Exactly. So for both of these guys, the domain is equal to this and the range is equal to this. Does that make sense?
Yes, thank you.
Cool. Also, as you can already see, my artistic skills are subpar, and that will be a constant throughout this quarter. Sorry about that. But so for this next one, for 11, there's actually infinitely many different ways you can come up with this. But the most natural way is if you wanted to break this up into two functions, you would do what's under the square root and then the square root itself. So if I have f of x is equal to the square root of x, then I would have g of x is equal to x squared minus 2x minus 3. And then if I were to nest them, I would get f of g of x is going to be equal to exactly what we have here. So the g of x would be x squared minus 2x minus 3, and plugging that into f of x would just put it under the square root. Does that make sense to people?
Yeah.
Cool. So this will be relevant later when you're doing something called the chain rule in calculus. Do people have any other questions that they want me to go over before I just start going straight through? Nobody? Okay. Cool. So we want to find the equation of a line that passes through the points -1, 5 and 3, 11. So how are we going to do that? What am I going to start off with?
Find the slope.
Exactly. So that's going to be y1 minus y2 divided by x1 minus x2. Sometimes people get confused because they're used to seeing it as like y2 minus y1 over x2 minus x1. It doesn't matter as long as you have the y value and the x value that are associated with each other on top of each other. So as long as I have the -5 paired with the -1 paired with the 5 and the 3 paired with the 11, we're good. So I'm going to do 11 minus 5 and 3 minus -1. Gives me 6 over 4, which we more commonly represent as 3.5. So now that I've found the slope, what am I going to do?
Find the y-intercept.
Yeah, we can do that. How do you want to go around doing finding the y-intercept?
Well, I was thinking of plugging in one of the coordinates.
Yeah.
For x, y.
Okay, so you were going to do y is equal to 3/2. So which coordinate do you want to do?
We can just do the first one.
Okay, so then we get -1 and 5 here. So we get 5 is equal to 3/2, sorry, -3/2 plus b. And then if I move that over, what do I get? B is equal to 13/2, right? So that is perfectly fine way of solving this guy. We get y is equal to 3/2 x plus 13 over 2. Another way we can do this, it asks, so this right here is called slope-intercept form. We can also put it in what's called point-slope form. And if we want to put it in point-slope form, we just pick one of the 2 points. So I'll just pick the other one. And we get y minus y1 is equal to, or I'm going to call that y naught, is equal to m times x minus x naught. And then if I just plug in those values, that gives me y minus 11 is equal to 3/2 times x minus 3. And this is also an acceptable way to write it. This is point slope form. You can also just rearrange this to get this guy. Does that make sense to people?
Yeah.
Cool. So find the slope and the equation for the line that is horizontal to find the slope and equation of the horizontal line passing through 2, 7. So what is the slope of a horizontal line?
It's the inverse of the regular slope.
0. I think the inverse thing, I think you're thinking of finding something that is perpendicular. So if you want to find the slope of a line that is perpendicular, you take it's -1 over the starting point, or your starting slope. But if we just want something that's horizontal, then we get m is equal to 0. Is equal to 0. And so that tells me that if I put this in slope-intercept form, I'm going to get y is equal to 0x plus b, or how we would normally write that is just y equals b. So if I plug in this point here, then I get y is equal to 7. And that is my equation for this line. Does it make sense? So another way to think about this is if it's horizontal, there's no x dependence. Cool. Let's say I'll do these 4. B doesn't add that much. So if I have 1 over x to the 4th, what happens when I have an exponent in the bottom of a fraction? What happens when I bring it to the top?
Becomes negative, the exponent.
Exactly. So this becomes x to the -4. And then this guy is something very similar. I can actually just think of this as this. And then what does it become? It's the same exact deal. I bring x to the up.
2x to the -5th.
Exactly. 2 times x negative. This guy, same basic deal. I just push the constant doesn't affect anything really. It's just a constant multiple. So my a it's just my a here. The a here is just an invisible 1, but obviously we don't normally write that. And then we get the x to the 4th gets pulled up again the same exact way that it did in a. Then here we have 1/6. Here we have something that's a little bit more complicated. We can go about this in either of 2 directions. I suggest changing the square root to a fractional exponent first and then moving up, but you can do it the other way around too. So what does the square root of x become?
X to the power of 1/2.
Exactly. So we get 1/6 times 1 over x to the 1/2. And then when I bring it up top, what do I get?
X squared.
Ooh, no. It doesn't flip the power.
X to the -1/2.
Exactly. It's the same exact rule. When I bring it up to the top, it stays the same. I just negate it. So then this guy, Andy, your mic is on.
Sorry.
No worries. So we get, what am I going to do with this? What is the cube root?
So you'll get x to the power of 4 to the power of 1/3, and then you'd get x to the power of 4/3.
Exactly, and can't forget that 2 up front. So that's going to be equal to x 1/4, because when we raise to a power, it's the same thing as multiplying the powers. So x to the a to the b is just equal to x to the a times b. And now, last but not least, what do I do?
The same thing, you just bring it up, so you'll get 2x to the power of -4/3.
Exactly. Perfect. Does that make sense to people? This is something that I think students tend to find fairly confusing, especially when you start mixing and matching. But it's just a few simple rules that you just need to remember how to combine them. Does that make sense?
Yeah.
Cool. So if we want to simplify each of these expressions, what am I going to do first?
You expand the bottom.
Yeah, so I factor I guess for both of these, I'm going to do top and bottom, but for this guy, the top is already factored. So how am I going to factor the bottom here? So I need two things that multiply together to give me -3 and add together to give me -2. So what things multiply together to give me 3? It's just 1 and 3, right? And which one of these is going to be negative?
The 3.
Yeah, exactly. The 2 is negative. That means that the bigger value is going to be negative when I factor. So that's going to be x minus 3 times x plus 1, x minus 3. And you guys should go through and check, like FOIL this out and see that, hey, this in fact does equal this. But I'll leave you to do that by yourselves. And then this cancels with this. And that should have also been a second hint that what it wanted you to do was actually just that you were going to find the x minus 3. Usually if it asks you to simplify, that means something will cancel. So we get x plus 1, or 1 over x plus 1 is our final answer. Does that make sense to people?
Yeah.
Cool. What about this? How am I going to factor the top?
You can factor out 2x.
Yeah, that's a good start to it. And then I get x squared minus 6x minus 40, right? And then how can I factor this guy? I need two things that multiply together to give me 40 and add together to give me 6.
X minus 10 and x plus 4.
Exactly. And if you don't just kind of see that immediately, just list out all of the ways you can get to 40. You can do 40 and 1, you can do 20 and 2, you can do 10 and 4, and you can do 8 and 5. I think that's all of the ways that you can pair these up. But this is the one that you want. So we get x minus 10, so that's equal to x minus 10 times x plus 4. and sorry, plus 4 and times 2x still. What about the bottom here? X squared minus 4x minus 32.
X plus 4 and x minus 8.
Exactly, x plus 4 and x minus 8. So again, the same thing. You can just break this down. You can do 1 and 32. You can do 2 and 16. You can do 4 and 8. And the bigger one has to be negative because this guy is negative. And you can just run through and see. So here, what can I cancel on both top and bottom?
X plus 4.
Exactly. So it simplifies just to 2x times x minus 10 over x minus 8. And you'd probably be fine just leaving it like this, but you can also do it as 2x squared minus 20x times x minus 8 if you feel like redistributing it through. Cool. So now go through and solve. Oopsies. Go through and solve some of these guys. Who hasn't spoken to me yet? Emily, how would you go about solving this? A.
Well, you can't take, would you subtract the 8 from that side or on both sides?
Cool. And then?
Could you take the cubed root of
Ex-
it?
Exactly. So if I do the cube root, then I get x is equal to -8, or sorry, is equal to -2, right?
Yes.
Cool.
Yeah.
So you could theoretically get 2 other answers because you're doing the cube root, just like how when you do the square root, you get both the plus and minus, but the other 2 answers are going to be imaginary or are going to be complex. They're going to have some imaginary part, and we only care about the real part. So we only get the real. Cool. And then we can do something similar here. Grace, what would I do for B?
First, you would start by adding 16 to the other side.
Okay. And now what do I do?
You would take like you would take like the root of 16, like square root.
Yeah, so you can start off by doing a square root, and then you get x squared is equal to plus or minus 4. But what am I going to do with this minus? What happens if I use that minus? What's the square root of a negative number?
It's not possible.
Yeah, it gives you an imaginary number, and we're not dealing with imaginary numbers. We're just dealing with real numbers. So we can basically ignore this. Does that make sense to people?
Yeah.
Cool. And then, so we can just do the square root again of this guy, and we get x is equal to
2.
2.
just 2.
Plus or minus 2.
Exactly. So this can be plus or minus 2. Does that make sense to people?
Yeah.
Cool. What about this guy? What am I going to start off doing here?
You can factor out 2 and x to the third.
Exactly. So this is 2x cubed times what I get, x squared minus 6x plus 5. Sorry, that's plus 6 plus 5 is equal to 0. How can I factor this guy?
You have x plus 5 and x plus 1.
Exactly. So I ask myself, what two numbers multiply together to give me 5? 5 is prime, so that means that it can only be 5 and 1. And guess what? 5 plus 1 is equal to 6. So that's going to work out. And again, you guys should go through and distribute this, FOIL it through to make sure that you can see why that works. So what does that tell me as the values that make this equal to 0?
Be x minus 5 and x minus 1.
And
Oh, and yeah, the 2x to the third there.
so
So you would have to factor that back in?
ooh, no, you don't.
Yeah.
When is so what this guy
equals 0.
exactly. So x cubed, 2x cubed is equal to 0 when x is equal to
0.
exactly. So I get x is equal to 0, x is equal to -5, or x is equal to -1. And so basically when we're factoring it through, we're just finding when any of the factors are equal to 0, because the whole expression is going to be equal to 0 only when one of the things that you're multiplying by is 0. So these are your three options here. You can also just write that as x is equal to 0, -5, or -1. What about D here? How would I go about that guy?
Factor out it. Actually, never mind.
Yeah, so you can go about factoring out the 2, and in general, we want the lead coefficient to be just 1. That makes things nicer. But and then you can go about factoring things, but we're going to be dealing with non-integers. We're going to be dealing with fractions, and that's a lot harder to deal with.
Quadratic
Luckily,
equation.
exactly. And do you guys know the quadratic equation song?
Yes.
Good. Do you want to sing it for me?
Oh gosh. Okay. It's x equals -b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah, exactly. Well, you didn't do too much singing there.
No, I didn't do the song. I'm sorry.
Yeah. So the song goes to the tune of "Pop Goes the Weasel," and you're about to learn that my singing isn't much better than my drawing. But x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And normally, if I had you in person, we would spend about 5 minutes singing that song till you all had drilled into your head. But I don't think that will work very well over Zoom. So you guys are getting off easy. Another thing that I'm going to encourage you to do is going to be just a bit easier. Actually, no, I won't bother with that. But if you want, you can divide the whole thing through by 2 at the start, and that means that all of your A's are just 1. But I'll leave it as is. So if I plug this in, so my B is -11. So I get x is equal to -11 plus or minus the square root of b squared. So that's -11 squared minus 4 times 2 times 12 all over 2 times 2, right? So that's x is equal to 11 plus or minus the square root of 121 minus 96, right? All over 4. What's 121 minus 96?
$25.
Exactly. What do we normally think of the square root of 25 as?
5.
Exactly. So all over 4. So I get x is equal to 16 over 4 or 6 over 4. And that means that this guy simplifies to 4 or 3 halves. Does that make sense to people?
Yeah.
So yeah, the quadratic equation is your friend. There are also actually cubic and quartic equations, but they are very, very messy. So if you guys want to look those up, you can see how bad they are to deal with. So what am I going to do here with E?
Don't you move the 10 over square root of x to the other side of the equation?
Exactly. And then what do I do after that?
And then you multiply both sides of the equation by the denominator, so square root of x, to get rid of it.
Cool. Now what do I do?
And then now you'll be left with 2 square root of x equals 10. And then you like divide the 10 by 2 to make it square root of x equals 5.
And finish me off here.
And then square root both sides by 2 to get rid of the square root, making x equals 25.
Perfect. Nice. So what about this guy? This one is a little bit interesting. What do I care about the bottom? Like, how does the bottom affect this?
It just can't equal 0.
Ooh, but I actually, so your function is undefined when x is, or when the bottom is equal to 0, but that's not really what is being asked here, right? Unless it happens to be that the top and the bottom are equal to 0 at the same spot, then you get something that breaks our equation here, but that's not going to happen. So I can actually just ignore the fact that this is equal to 0, right? Because this whole equation is going to be equal to 0 only when the top is equal to 0, right? So I can just ask, when is 3x minus 1 equal to 0? And when is that going to be?
When x equals 1/3.
Yeah, exactly. So I move the 1 over to the other side, and then I divide by 3, and I get x is equal to 1/3. And if I'm asking like, hey, when is this going to be 0 or undefined, then I have to worry about what's going to happen on the bottom, because it'll be undefined when I divide by 0. But I'm not asking that. I'm just asking, hey, when is this equation going to be equal to 0? So I only have to worry about the top then. What about this guy? How am I going to start that off?
You take out e to the power of x.
Cool. So I get
So
easy.
x, yeah.
And now, sorry, finish off.
Yeah. And then you do e to the power of x equals 0, and then x minus 7 equals 0.
Yeah, exactly. So it's when either of these guys is equal to 0. So when is x minus 7 going to be equal to 0?
It'll be positive 7.
Yeah, so we got x equals 7. When is e to the x equal to 0?
It'll be no solution.
Exactly. And we did that down below when we were dealing with, I think, question 10 or 11. But so that means that it's only going to be at x is equal to 7. What about this guy here? H. Get 4. Right? That's probably how we want to start it off. Then what am I going to do? Well, I want to get rid of the ln, right? So how do I get rid of ln?
E to the 4th equals x?
Exactly. So we don't really have a nice word for it. I'm going to call it basing it to the e. And then we get e to the fourth. E cancels with ln. So e to the fourth is equal to x. And that solves our equation here. What about this guy? I'm going to start off here, right? Then what do you think I'm going to do? Next thing that I'm going to do, I'm just going to divide both sides by 6. Get rid of this 6 right here. So divide both sides by 6, and I get e to the 6x is equal to 1/6. Now I want to get rid of this e, right? How am I going to do that?
Would you take the natural log?
Yeah, so I take the natural log of both sides. So I get ln of e to the 6x is equal to ln of 1/6, and ln of e to the 6x is the same thing as 6x ln of e, and ln of e is just 1. So that's just the law of logarithm that you guys should know. If you have a log of something to a power, you can just pull that power out front. That is just one of the laws of logs. So we get 6x is equal to ln of 1/6. What am I going to do now? Let's finish this off.
Divide by 6.
Exactly. So divide by 6, divide by 6. And finally, I get x is equal to 1/6 ln of 1/6. Does that make sense? Cool. So f of 64 in this equation, I'm literally just going to plug it in. So I'm going to so the first thing I'm going to do is I'm going to change this guy to the cube root of x squared. And that's the same thing because both of these guys, cube root of x squared, and both of these guys are equal to x to the 2/3. But this order is going to be easier to work with. So what happens when I plug in f of 64 then? Everywhere I see an x, I plug in 64. We get 5 times the cube root of 64 squared. What's the cube root of 64? So it goes 2, exactly, 4. So 4 squared is?
16.
Exactly. So I get 5 times 16 minus 24 times the square root of 64. What's the square root of 64?
8.
Exactly. So we get 8. What's 24 divided by 8?
3.
Cool. So we get 80 minus 3. I skipped a step. 5 times 16 is 80. So 80 minus 3 is?
77.
Cool. Perfect. About 7 here. This is actually, this one is, there's a quick trick to this if you remember it, but if not, then it's kind of a pain. Yeah, exactly. The negative b over 2a is the quick trick. Thank you, Aaron. And that actually comes from the quadratic equation that I mentioned, or that we used earlier. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the midpoint between these guys is going to be negative b over 2a. And like you can see that one of them is just going to be plus this and the other one's going to be minus that from it. And for a parabola, it's going to be the vertex is going to be halfway between, it's going to be the midpoint between my two zeros. So what happens if I plug in negative b over 2a here? So I would get negative 8 over 2 times negative 2. And that would be equal to, so negative 8 over negative 4 is equal to just regular old 2. So the vertex occurs at x equals 2. And then what do I do to find the actual vertex? What do I do to find the actual vertex here?
You plug in.
Exactly. Plug and chug, exactly. So I just do f of 2 is equal to negative 2 times 2 squared plus 8 times 2 plus 11. So this guy right here becomes negative 8. This guy becomes plus 16. This guy stays as plus 11. And when I combine those, I'm going to get 19, right? So we get 219. And then the other thing that we have to ask is it a happy face or a sad face? Does it?
Sad face goes down.
Exactly, it's sad face because the lead coefficient is negative. So that means the parabola is going to be facing downwards. And that tells me that it's actually going to be, the vertex is actually going to be the highest point right here. So it's going to be the highest point, and it's going to occur at 219. So then so we have 8 minutes left and 3 problems. I'm going to do all of 8, and then I'll probably just pick 2 or 3. Would you guys prefer that I do 8, 9, or 12? Like, what's the priority here?
I believe 8, but that's just my opinion.
Okay. Since you're the first one to speak, I will go with your opinion. So find the domain of this guy without graphing, although one should be able to graph this. So we're going to scroll down a little bit. So from negative, so the domain is like where this is going to be defined, right? So is from negative 3 to 0, does this make sense everywhere? The answer is yes, because you're not dividing by 0, you're not putting like a negative number into a square root. You're not doing any of those things that will break the equation. What about from 0 to 2? Is this guy well defined? Is this going to break anywhere? Yeah, so we're good. And then from 2 to 6, 5 is just a constant function. It's going to be perfectly well defined everywhere on there. So the next thing I have to do is ask, what about the areas of transition? So like, is it going to break when I transition from negative or from 0 to from just less than and including 0 to 0? No, I think is this even continuous? So it's 2, and so it's not continuous, but that's fine. We don't have to be, we don't care if it's continuous for this question. And we'll get something similar over here, although this one actually will be continuous. So what does that tell me? So it's defined on the borders. So what does that tell me? So this guy is -3 to 0, union 0 to 2, union 2 to 6. Does this cover every single number in any interesting range?
Yes.
What range? Also remember this, like the parentheses means that it's not inclusive. The brackets mean that it is inclusive.
I think I misunderstood the question. Can you rephrase?
What interval is this defined on?
For the range.
No, for the domain.
-3 to 6.
Exactly. And is that inclusive or exclusive? Do I include -3 and do I include 6?
Yeah,
Inclusive.
Yeah, so I include both of them because we have less than or equal to and less than or equal to, right? Cool. So we only have 4 minutes left. Do you guys want me to do, so I'll run through 9 very quickly. This is a positive value, so it doesn't matter if I'm raising it to odd or even, it's going to be positive. Same thing here. So 1/2 to the 3rd is going to still be positive 1/8. This guy's going to be positive 1/6. Where it becomes interesting is here. Negative numbers raised to an odd power are negative, right? So if I have -2 squared, then that's going to be positive. But if I have -2 to the 3rd, that's going to be negative. And that's going to tell me the same rule here. So if I raise it to a positive, or if I raise it to an even number, what's it going to be?
Positive.
Exactly. And I will see if I can do this in the next 3 minutes. And if so, then you will have had the entire thing. Also, I'm pretty sure next week is a university holiday. I'm not actually sure why, but I don't think that there's going to be a meeting for this recitation. If you want, you can show up to, I'll share the information for either my other recitations, but I'll also be posting a video from one of them. So where's the vertex here? It's -b over 2a, right? So that is -2 over 2 times 1 is going to be equal to 2 over 2 is equal to 1. So it occurs at x equals 1. Then if I plug in x equals 1 here, what do I get? I get 1 minus 2 minus 3 is equal to -5. So what is my vertex? My vertex occurs at 1, -5 then. And then what are the zeros of this guy? So screw it. Basically, you find the vertex, you find the zeros, and then it looks like this. If I were to factor this guy out, I would find it's equal to x minus 3 and x plus 1. So when I clear that and scroll back down, I get x is equal to 3 and x is equal to -1. And I get the vertex down here. And I look something like this. Actually, I should probably find the y-intercept, but due to the fact that we are out of time, I'm not going to do that. But if you have those 4 pieces of information, you can give a pretty good drawing of what's going on. Any last questions before you are all free? Okay, have a nice day.
Thank you.
Thank you.
Thank you,
You too.
Professor.
Thank you.